Hi everyone. Hi everyone. Apa khabar? Apa khabar anda? Halo, apa khabar?
Kabar baik.
Kabar baik.
Bagus. All okay, semua okay? Okay, today I want to start with one latihan. I sent to the group very soon. Okay, let's start with a simple latihan first. Electricity, then we go back to electromagnetism. Start one simple latihan, electricity, then thank you, Sandra. Okay, 34. Very good. Mr. Pang. Hello, how are you, Mr. Pang? Hi, Darshana. Okay,
I'm fine,
good,
teacher.
good. Thank you. Zizan. How are you, Zizan?
I'm fine.
Thank you. Sean, Sati, Sandra, Ruby, Shwan Singh, Pratisha, Nigel, Shaira, Kalok, Marcus. Yes, Sean. Okay. All right. I think we start. Okay, look at this question. Okay, this is a simple latihan today. Right. Diagram 1.1 and 1.2 show bulbs connected at the fruit stalls. Okay. The type of the bulbs and the EMF are identical, same. That means the resistance of the bulbs and the battery voltage all are same. Okay. Next, see here. What is meant by EMF, electromotive force? Okay. So EMF, let's call Mr. Alim. Alim, what is EMF, Alim? Hi, Alim. Selamat berpuasa, Alim.
Hai, Syah.
Selamat berpuasa. Syahira, Alia, semua selamat berpuasa.
Thank you, Syah.
Okay, Alim, what is meant by EMF, electromotive force?
The amount of work done to
Alright.
carry
Alright.
one column of charge
Very good.
throughout the circuit.
Very good. That's the answer. The amount of work done. The amount of work done. The amount of work done to carry one column of charge, throughout the circuit. Right, throughout the circuit. Very good. That is EMF. So what is EMF? The amount of work done to carry one column of charge throughout the circuit. Siapa tak faham? Siapa ada masalah? All okay? All okay or not?
Yeah.
Okay, nah? Very good. Thanks. Okay, next. Draw a circuit diagram for each circuit and label the type of circuit. When I see both of the circuit, I realize that, okay, the first one is series, the second one is parallel. Can you see that now? First one is series, second one is actually parallel. Can you see that? First one is series, second one is parallel. Okay, now. So draw a circuit diagram for each circuit and label the circuit of type of the circuit. Okay, let's look at it. First one is parallel, second one is circuit. So for the first one, we can draw like this. The first bulb and the second bulb, right? and there's a switch here. There's a switch here, okay? Then for the second one, we can draw the switch is here, right? We can draw first bulb, second bulb. That's it, the connectivity, power source. So label, you all label lah, you label lah. Bulb, connecting wire, dry cell, switch. Bulb, connecting wire, switch, dry cell. So minimum ada 4 label. Bulb, connecting wire, dry cell, switch. You all got it? This is the sketch. This is how you have to sketch. You have to sketch and show the circuit. Okay, next. So draw a circuit diagram for each circuit and label the type of circuit done. Okay, now. Diagram 1.3 shows an electric kettle with specification of 240 volt, 2000 watts, and connected by a flexible cable to a 3-pin plug. Okay. No, just now you're able to draw or not? Sean, can draw this or not? Sean? This is faster. Okay, I go slow lah. Sean, these 2 circuits you draw or not? Okay, Sean, this, yeah, okay. Sean, you draw these 2 circuits. This is series and parallel. Okay, these 2 done. Okay, then you have to label switch, and then dry cell, bulb, connecting wire. This is connecting wire. So all of you have to label everything. You have to label the switch, you have to label the dry cell, you have to label the connecting wire, and you have to label the bulb. So you have 2 circuits to sketch, all of you. Okay, done. Okay, now you see this diagram. The diagram shows an electric kettle with specification given. 240 volt, 2000 watts. 240 volts, 2000 watts. And connected by a flexible cable to a 3-pin plug. Okay. You are required to modify, you're supposed to modify the design of the electric kettle so that it can boil water in a shorter time and has better safety. So safety also must have and must boil faster. This one must boil faster, and must have the safety. Okay. So now, read the question, guys. You are required to modify the design of the electric kettle in diagram 1.3 so that it can boil water in a shorter time and has better safety. State and explain the modification. Okay. But this is actually the electric kettle. Okay, first thing, the diameter of the wire used as flexible cable. Okay, let's look at it. Okay. Okay. Flexible cable. The flexible cable, the diameter must be thick. Why must be thick? This is the flexible cable outside of the kettle, must be thick so that thicker diameter, lower resistance, higher current. Okay, so flexible cable must have a thicker diameter, lower resistance, higher current. Okay, so there are 4 things we have to look at. First was the diameter of the wire used as flexible cable. So this is the flexible cable, right? This is the flexible cable. See here. This is the flexible cable. So this is the flexible cable. So flexible cable, better make it as thick wire. Okay, done. Flexible cable. Length of the cable. This flexible cable, the length of the cable, length of the cable. We want to have a shorter length. Why we must have a shorter length? Shorter length. Why must have a shorter length? So that we can reduce. Shorter length, we can reduce. Shorter length, we can reduce the, so length of the cable. Shorter length, reduce the resistance. Resistance across the cable. Okay, done. All right. Length of the cable, shorter length, reduce the resistance across the cable. Right. Okay, next. Type of heating element. The third one, now they're going for the heating element, or type of the heating element. Okay, what is the type of heating element can we use? Okay, let's call Alfred. Alfred, Alfred, how are you, Alfred? Hi, Alfred.
Yes, I'm
Yes.
very good.
What is the type of heating element can we use?
Like chrome.
Nichrome or tungsten, something like that lah. Okay, let us don't name it. Okay, don't name it first, but let us tell that the type of the heating element used must have one characteristics. It must have a very low resistance or high resistance.
High.
High resistance. So a material with a high resistance must have, remember this part or not? Higher resistance shows higher resistivity, yes or not? So material with a higher resistivity will have high resistance. Got it? Alfred?
Yes.
Alfred, yes. So if you are choosing a heating element, the heating element must have higher resistivity. Higher resistivity. Okay, so if we are choosing a heating element, all right, it must have, okay, heating element. Heating element must have higher resistivity. Okay, why must have higher resistivity? Resistivity. Okay, why must have higher resistivity? Heating element must have higher resistivity. Why must have higher resistivity? So once they have a higher resistivity, they'll have higher resistance. So when they have higher resistance, they can heat up faster. They can heat up faster. That's the reason. So when you have heating element with higher resistivity, they will have higher resistance, so they can heat up faster. That's the reason. So first we look at flexible cable, thick diameter. Why? Lower resistance. Yes, Sean. Oh, yes, higher resistance, lower current, but this is for heating element. Heating element must have higher resistance so that it can heat up faster. heating element. That's why the cable, the flexible cable just now, we want higher current. So flexible cable, we want lower resistance but higher current. But this one is the heating element. Heating element, we want higher resistance so that its temperature can increase faster. So of course, the side effect of it is that the current inside will be lower, but we want it to be a heating element. What? So we are not bothered about the current flow. Okay, Sean? Okay, now diameter of wire done, length of cable done, type of heating element done. Let's go for the next one. Type of material used as the body of the kettle. The body of the kettle, okay. Kettle, you know. The kettle, we have two options. One, it can be a plastic or it can be a metal. So I'm going to go for the, who erased my screen? Who erased my screen? Undo again. Alamak. Somebody erase what I typed just now. Oh, it's there. Okay. It's there. Sorry, boss. Okay, now. So, sorry, boss. Okay, now. I tak nampak tadi. Okay, now. It went off and came back. Ada hantu, ada ghost. Okay, see here. Now, if you look at it here, the body can be plastic, can be metal. But the characteristics of the body, the type of material used as the body of the kettle, got actually two. First characteristic, body. Okay. Now we go for body of the kettle. Body of ceramic or expensive, Sean Kern. Body of the kettle. Back our household use ceramic ma. Body of the kettle, number one, low density. Low density. Why must have low density? Portable. Lighter. And portable. Lighter and portable. Number two, it must have body of the kettle. Another thing, the body of the kettle must have high melting point. Must have high melting point to withstand high temperature. To withstand high temperature. So this is the first idea. The kettle that we use, right, must have low density. The kettle we use must have low density. Why must have low density? Because once low density, it's lighter and portable, easy to carry. Lighter, portable, easy to carry. High melting point, so that to withstand high temperature. And I said the body can be plastic, very high melting point plastic, or metal. But most of it, they choose metal. The body is actually a kind of stainless steel. Stainless steel. Stainless steel is a conductor of electric. Look at the next part of the question. Okay, safety precaution. Type of material used, done. What is the safety precaution that we can have? What is the safety precaution can we have? Safety precaution. What is the safety precaution can we have? Safety precaution. Who want to try? Let's call Alicia Ong. Safety precaution.
I don't know.
Sure or not?
Yes.
Yeah. Okay, yes, correct. To make sure to make sure it is connected with earth wire. Connected with earth wire. Okay, you don't pour so much, Sean. You don't pour until the level. That's why it's always there. Very good, Sean. Yes, I was about to tell that. Yes, to make sure it is connected to earth wire to prevent leakage. Connected to earth wire to prevent leakage, guys. This is to prevent leakage. Okay, connected to earth wire to prevent apa dia? When there's a leakage or you're not electrocuted, to prevent apa tu? To prevent what they call it, so that we will not be electrocuted if there, in case there's a short circuit. To prevent leakage electric current. Earth wire, so that in case of a short circuit, in case of a short circuit, so that in case of a short circuit and leakage of current, we will not be electrocuted. Electrocuted. Okay. To make sure it is connected with earth wire so that in case of a short circuit and leakage of current will not be electrocuted. And one more thing, yes, it can be connected to a fuse, because the fuse can protect the device. Connected to a fuse, the fuse can protect the device. So we come back, we have completed. First thing, flexible cable, thick diameter, lower resistance. Length of cable, the cable connecting to the electric kettle must be short. Heating element must have high resistivity, so the higher the resistance, it can heat up faster. Body of the kettle, low density, lighter and portable. All right, okay. And to withstand high temperature. Okay, now safety precautions, to make sure it is connected with earth wire so that in case of a short circuit and leakage of current, we will not be electrocuted. Connected to a fuse. All right. Can anyone record this and send to me? I'll go through the question again. Who can record now? For one minute only enough. Anyone can record now? Anyone? Let's say I ask Mr. Yi Ching. Mr. Yi Ching, where is he? Okay. Allowed to record. Okay, record Mr. Yi Ching. Now starts now. Okay, if you look at this question, all right, this question we have to find the properties of the wire connecting the electric kettle, and then the heating element in the electric kettle, and the type of material of the body of the electric kettle, and the safety precaution of the electric kettle. So what we can do here is that for the wire connecting the electric kettle, we can actually use a cable which is very thick. So when the cable has a thick diameter, resistance will be lower and higher current can flow. For the length of the cable connecting the kettle, it has to be a shorter cable to reduce the resistance across the cable to increase the energy efficiency. Right? The heating element used in the cable must have a very high resistivity so that the material have a very high resistance. We can heat up the water faster. For the body of the kettle, it must have a low density. When the material having a lower density, we realize it's a lighter and portable material. And it should have high melting point too, because once we started boiling, the kettle will be exposed to a very high temperature. So when the material of the body has a very high melting point, it can withstand a high temperature without melting. Finally, the safety precautions is to make sure it is connected with earth wire so that in case if there's a short circuit or leakage, we will not be electrocuted, because there's a possibility the current can flow to the body of the metal. So to prevent that, we have the earth wire. And finally, it can be connected to a fuse, because a fuse can disconnect the current in case there's a high current flows to the kettle to protect the kettle. All right, thank you. Yicheng, done. Yicheng, done. Thank you. Okay, we continue, guys. Okay, done. Thank you. Okay, this one done. Okay, thank you. So this question done. All right, now we go to the next question. This one you all pula cuba. Huh? Okay. Diagram 2.1. Today attendance good or not? 39. Okay, not okay. Still got some plus missing. This Mr. Monitor of 5 Pascal, please tell your class teacher Terence and his partner, what the first name? Jashan. All the time missing class only. Correct, right, Jordan?
Yeah. Yes.
Yeah. Your other class also they'll miss lah.
Yes.
Ayo, manya susah lo. Okay, what to do? Let's try number 2 now. Okay, all of you try, yeah? Diagram shows a circuit used to investigate the relationship between current and potential difference of a constantan wire. Current and potential difference of a constantan wire. Okay. So diagram 1, notice or not, the wire is longer. Diagram 1, the wire is longer. Diagram 2, it's a shorter wire. Both diagram shows ammeter reading is same. You might ask, how can be? Can. They might have controlled the rheostat value. Both diagram shows the same reading of ammeter because maybe this value was controlled already so that they get a constant current value. Okay, because we only want one manipulated variable because the manipulated variable is the length. All right. So responding variable is only one, the voltmeter reading. So we do not want this. So they make the current equal, right? Okay, and then we continue. Okay, what is the meaning of electric current? Okay, let's call. Nobody type, nobody type, don't type. Okay, Jaying, what is electric current?
Rate of flow of charge.
Very good. Okay, done. Who don't get it? Electric current is rate of flow of charge. Who don't get it? Semua okay? Okay, just a recap. Let's call Avril. Avril, what is potential difference? Avril, what is potential difference, girl? Wow, so long your
Oh no, I forgot already.
yeah, potential difference. Okay, Celine Chong, helper. What is potential difference?
Oh, I don't know.
Alamak. Marcus, help them. I know you know one. Marcus, potential difference.
You don't know me well enough. I don't know.
Alamak, Marcus. Potential difference. Okay, you follow me, Marcus. Potential difference is the amount of work done. Marcus, repeat.
Yes. Amount of work
Potential
done.
difference. Potential difference, the amount of work done to transfer. Tell, repeat.
Or to transfer.
Amount of work done to transfer one column of charge.
To transfer one column of charge
From one point to another.
from one point to another.
Okay, very good. What is potential difference? Amount of work done to transfer one column of charge from one point to another. Okay. Now we look at, let's call Jayu. Jayu, hello. Hi, Jayu. Hi, Sheila. Jayu. Yes. What is Ohm's law? Ohm's law. Tiga yang penting. Electric current, potential difference, Ohm's law. Lima lah. Electric current, potential difference, Ohm's law, EMF. Empat lah. Yes, what is Ohm's law, girl? Come on. Kalok, answer, what is Ohm's law?
Electric current is directly proportional to the potential difference when the temperature and other physical conditions are constant.
Very good, boy. Thank you. Very good. Okay, we call itu head boy. Mana itu head boy? Joshua.
Yes.
Yes. What is electric current?
Rate of flow of charge.
What is potential difference?
The amount of work done to carry one coulomb of charge between 2 points.
Very good. What is Ohm's law?
The potential difference is directly proportional to current when
Yes.
the other physical factors are constant.
When the temperature and other physical conditions are constant. Hey, wait, there's no Kalok, so electric current directly proportional to potential difference, right? Kalok, terbalik Kalok. Potential difference is directly proportional to current. Okay, one more. All right, Joshua, one more.
Yes.
EMF.
Amount of work done to carry one coulomb of charge throughout the circuit.
Okay, very good. Done. Thank you very much. Okay, done with that. Using diagram 1, and I send the link for 145 video, guys. Okay, and then I send this also to the group, I sent 2 worksheets to the group today. Okay, I send this also. This one, whatever you can do, you can start doing a day. But induced current, I haven't started a lot a day. I just explain simple one. This one got transformer. Okay. Maybe we will have a slot. I'll let you all know when lah. This budak-budak Pascal, you all got class at 2, right? Computer science all, Betul kan? Hello.
Yes.
Yeah. Okay. Okay, this one done. Okay. Using diagram 2.1 and 2.2, compare the ammeter reading. Okay, first point. Ammeter reading, Sean. Ammeter reading, same or different? Both Sean. Both Sean's are they ready? Okay, same. Very good. Sean Kern and Sean Wong. Okay, thank you. Same. So ammeter reading is the same. Voltmeter reading. Sean's. Different. How to tell? Which one is bigger, which one is smaller? Which one? 2.1 is higher than 2.2. Okay, very good. 2.1 is higher than 2.2. voltmeter reading. Okay. Voltmeter reading. Length of the wire. Length of the wire, the boys. You need eye test lah. Testing your eyesight, okay or not? Different, how to tell different? Must tell. 2.1, the wire is longer than 2.2, yes or not? Yes, the wire in 2.1 is longer than 2.2, very good. And then relate the voltmeter reading with the length of the wire. Okay, so now you tell Sean Wong, relate the voltmeter reading with the length. Mister? The longer the wire, yes, the longer the length of the wire, the higher the voltmeter reading. And that one, the second part, Sean. Yeah, yes. Relate the volt, yes, Sean, correct. Relate the voltmeter reading with the length of the wire. So the longer the length of the wire, the longer the length of the wire, the higher the voltmeter reading. So how to give a relevant physics concept? We tell the increase in the length of the wire, increase in the length of the wire, increase the length of the wire, increase the resistance across the wire, therefore potential difference increases. So increase in the length of the wire, increase the resistance, increase in the resistance, increase the potential difference. Done that part. Okay. Who got problem? B. So ammeter reading, both diagram 2.1, 2.2.
Wait, can repeat the B. Increase
B,
the resistance.
I'm repeating the whole B now.
Oh, okay.
Okay. B, ammeter reading, diagram 2.1, 2.2, same. Ammeter reading, diagram 2.1, 2.2, same. Voltmeter reading, 2.1 is higher than 2.2. Length of wire, 2.1 is longer than 2.2. Then you must tell the longer the wire, the higher the voltmeter reading. Or you can tell increase in the length, voltmeter reading increase. And then the concept you must tell, increase in the length, resistance increase, increase in the length, resistance increase. So when the resistance increase, the potential difference increase. So when the length increases, the resistance increases, so the potential difference increases. All right. Siapa ada soalan? So ammeter reading, both ammeter reading was equal. Diagram 1, diagram 2. Voltmeter reading, diagram 1 greater than diagram 2. Increase in the length, voltmeter reading increases. Okay, any question, guys? Okay, done. Next, explain the properties of an ohmic conductor and give an example of it. All ohmic conductors will have a constant ratio of potential difference across electric current. When they have a constant ratio of potential difference across electric current, that means they are having a constant resistance. So if it is an ohmic conductor, it will have a constant ratio of potential difference to electric current, constant ratio of potential difference to electric current. Okay, ohmic conductors, constant ratio of potential difference to electric current, and then number 1, number 2, constant resistance. constant resistance. Right. Number 3, ohmic conductors should not show an increase. Ohmic conductors should not show, yes, Icheng, daging ayo. So properties of ohmic conductor. Give me a few more minutes, then I'll resume. Okay. I will give you all time. Okay, to get ready for the next class. Okay. Now see here. Properties of ohmic conductors. Number 1, they'll have a constant ratio. Constant ratio. Constant ratio of potential difference to electric current. Number 2, they'll have constant resistance. Number 3, should not show an increase in temperature. They should not show an increase in temperature. Example, I gave you the good alloy of copper and good alloy of aluminium. Should not show an increase in temperature, good alloy of copper and good alloy of aluminium. Clear? Any question, guys? Boleh ya? Okay. Done. Okay, let me go through this. Okay. I just explain this to you all. Then later you all try to do this and send to me. You can send to me before tomorrow. Tomorrow 4 p.m. So you got time. Okay, see here. Diagram shows a filament bulb labeled 240 volt and 80 watts. Okay, that's a filament bulb. Okay. You are required to modify the design of the filament bulb so you have to redesign the filament bulb. Just now was heating element, now filament bulb, almost similarly. That's why I choose the same question, so that it can light up with normal brightness. When they say normal brightness, always remember, guys, when they say normal brightness, if the label is 240, that means they get 240. When a bulb labeled 240 receive 240 volt, it will be at normal brightness. Okay, now state and explain the modification based on the following aspect. Okay, first aspect, type of material used for the filament. It's similar like the heating element just now. Heating element, you choose higher resistivity. Heating element, you choose higher melting point. Give reasons. Higher resistivity, higher melting point. Give the reasons. Then shape of the filament coil and thickness of the filament coil. Shape and thickness. Okay. The shape, you see, it's a coil. It must be a coil. Why coil? To increase the length. Why coil? To increase the length. The longer the length, the higher the resistance, the higher the temperature produced. All right. Thickness, it has to be a thin wire. Why thin wire? Cross-sectional area smaller. Thinner wire, smaller cross-sectional area. Smaller cross-sectional area, higher resistance across the wire. Alright, higher resistance across the wire, or melting point I explained earlier, yeah. Okay, now. Okay, melting point done already. So almost all I explained already. So when you have a filament bulb, you must know how to choose a filament bulb. Alright. We also can add on rate of expansion. It must have very low rate of expansion. Must have very low rate of expansion. Must have a very low rate of oxidation, because expansion rate must be low because of why? It will be heated, expand, then contract, heated, expand, then contract. So during this process, it can snap easily. We don't want that to happen. Most of the filament bulb those days have thickness must be thinner, thin wire. Thinner wire, smaller cross-sectional area. Smaller cross-sectional area, higher resistance across it. Okay, thank you. So these are the points. Who got problem with the points, guys? Who got problem with these points? Siapa ada masalah with these points here? Anyone? Yes, Kalok. Higher resistance or lower rate of expansion. Lower rate of expansion. So expansion, yes. So it won't snap. Dia takkan putus, break, because it is constantly heated while it's used, and also it will go through contraction again. While using expand, while not using contract, right? So during that process, we do not want it to snap easily. Understand? Boleh ke? Okay. All right, guys. I think that's all for today. But before we end the session, all right, boleh tengok muka ke?